Hello, my name is Miss Mary and I am the AP Chemistry instructor with 7EDU. Now, by the end of today's video, I want you to walk away with strategies that will help you feel more comfortable and confident as you tackle the AP Chemistry exam. So when approaching your AP chemistry problems, whether it's an FRQ or a multiple choice question, there are a few things that we need to consider when approaching these problems. The first is to identify the problem. Okay, so identify. So this is where we look at the categories of the concepts that you've learned. So for example, am I dealing with a stoichiometry problem? Or am I dealing with a Le Chatelier problem? Right? These are the topics that we are considering when you are doing a chemistry problem. The second thing you need to do is to consider what is true about this problem. Okay, so these are where we think about the givens, right? If they have given values, right? This is where we think about equations that we might need to apply, right? This is where we think about the concepts, right? And the conceptual relationships between one part of the type of problem we're looking at and something else. So for example, the relationship between pressure and volume, if we're talking about ideal gas laws. So those are the two things that we need to consider. When you're looking at what's true, we want to be able to annotate. Okay, so don't be afraid to use your trusty pen or pencil to ensure that you are underlining and circling and noting the things that are very, very important in your understanding of that question. Okay, and of course, the third thing is to solve. Okay, so based off of all these things, you go ahead and solve. So this is where you apply the equation that you thought about in 2. This is where you actually go ahead and maybe provide the reasoning based off of the relationships that you know are true in the concepts that you have here. Okay, so now we're going to take these strategies and apply it to some FRQs. Like now I said, you can look at the multiple choice questions, or you can also look at the free response. No matter what, they should work. So let's try that out. Problem-solving strategy that I mentioned earlier, but look at this problem in an FRQ from an old AP chemistry exam problem. So we're going to start with the first question. A student performs an experiment to determine the value of the enthalpy change delta H reaction for the oxidation reduction reaction represented by the balanced equation above. So we have our balanced equation above. A, determine the oxidation number of Cl and NaOCl. Now let me just go ahead and have my annotation tool because I said that was important. Okay, so the oxidation number. So remember, the first step is to identify. Now you're going to find that some questions are going to tell you straight off the bat what the problem is. So in this case, that is definitely the case. This is an oxidation number problem, right? So we have to think to ourselves now, what do we know is true about oxidation numbers? Well, we know that there are rules for oxidation numbers. So as you are reviewing this with me, as you're reviewing an exam with me, I will ask you what the problem is, 1, and 2, what do you know is true about it? If you find yourself struggling with trying to tell me what kind of problem it is, that's usually going to be an indicator that we need to review that concept. So what I would probably do is make a note to assign you problems from like an AP chemistry prep book. Barron's is one I recommend, and you would be doing problems related to that concept, so that way you're doing well in it. Now in this case, of course, oxidation numbers, there are rules. We knew that for something like Na, that is in that first period on the periodic table, it would have a +1 charge. For oxygen, because this is, not in a peroxide, this would be -2. And because this is overall has a charge of 0, chlorine must have a charge of +1 for it to balance out to 0. So chlorine has a +1 oxidation number. Okay, so that's how that would look like. Now let's look at B. It says calculate the number of grams of Na2S2O3 needed to prepare 100 milliliters of 0.5 molar Na2S2O3 aqueous. Now, this one is interesting because unlike A, this doesn't explicitly tell you what type of problem it is, okay? So I would ask you still, what type of problem is this? And you should be able to note that we are dealing with stoichiometry. Now, whenever you're dealing with stoichiometry, I generally encourage students to give me a schematic of what that will look like. So for example, I have here the volume in milliliters and the molar value. Now I'm looking for the mass, grams. So what I'm going to need to do is determine the moles using the molar equation, right? Of course, this would need to convert into liters, right? So that would look like 0.100 liters, right? And then I would also need to consider the fact that I would need to rearrange this equation. So that would be moles is equal to the molar value times the volume. Okay, then I need to make sure that I turn that moles into grams, right, using dimensional analysis. So with that schematic, I should be able to get the answer. Now, when we're doing review, this is the kind of thing I'm going to be asking you to show me. So before you're even trying to get into the problem to solve it, if you can show me the schematic or explain to me the strategy that you're going to use to get that, that shows preparedness. If you're looking at it and you're very unsure of what to do and you're not sure what game plan that you have, that usually indicates that we need to do more practice. And in those cases, I would note it with an asterisk, right? And maybe right off to the side, because we're identifying this as a stoichiometry problem, right? This is stoichiometry. Okay. All right. So that is a way that I would, go ahead and prepare, right? Is being able to identify, ask yourself what is true, and going ahead and solving. Now, solving, I haven't done that yet, but the point here is to kind of show what a review would look like. And I actually prioritize this over the solving because this is where the understanding comes in. Then the solving is just making sure you're careful with the calculations, right? But if you understand the math behind it, if you understand the chemistry behind it, you should be able to be successful with the solving, so long as we're careful with that. So I am pleased to present this little snippet of what a review would look like. But yes, keep those strategies in mind of identifying, determining what is true, and then solving. Don't be afraid to annotate and put asterisks on the problems that you feel like you need more help with. So thanks for joining me today, and best of luck on your preparation for your exam. Bye-bye.